weren't quite sure about, and then we're going to talk about domain and about range, okay? So the first graph we did in class together, right? This guy here, part A. Okay, so we found all the stuff, we marked all the stuff, we went through the analysis. We understand the highlighting is not part of the graph, but it's me trying to visually show you in your notes when you're doing the analysis how it corresponds to what you're able to graph on the graph. If you want a highlighter during your test and you want to highlight, go for it, by all means, okay? I just want to make sure that like when you look at one of these graphs in the future, you're not like, why didn't they highlight? Because that's not a part of it. That's us processing what we're supposed to be doing, okay? So when we look at this first graph, we did this one together, so I'm going to talk about domain and range on it, and then as we go through each of the other ones, I'm going to let you guys ask questions about like a couple different things. Like first, the list of characteristics. Second, like the analysis and where we graphed stuff. And then thirdly, we'll talk about the domain and range. Morgan?
When we do these on the test, will we have more time to do them than like when we're doing the video?
So on the video, I was just going through. So we've given a test with the same amount of material on it for several years and feel that it is a fair amount of material. Now, with that being said, if you don't know what you're doing, the problems are probably going to take too long because they involve a lot of stuff. So if you don't know what you're doing, then it will take a little bit longer. Okay, but we've given the same, it might look a little different, the test format and all this, but the same number of like graphing problems and other problems on the test or less during the last like 6 years that I've taught. Does that give you any comfort with what for that? But you do have to know what you're doing. These are long, so like if you don't know the process, it's going to take longer to get caught up in it. So that's why it's super important that we know what we're doing. Okay, but the video is me just like talking through, and it's definitely harder when you're learning it. You saw how long the one in class took us because I was taking questions versus the one on the videos, which I tried to make a statement at the beginning about pausing it or like doing what you guys needed to do while you were copying it, because I'm trying to like I'm sitting there by myself recording it. So like I'm not pausing or anything during that time because you guys can do that before. So that was probably like a short version of it, you know? All right. So this problem right here we did in class, made the list, did the analysis, got the graph. So let's talk about domain and range. So domain, there's kind of like a procedure, those of you that love like, oh, pattern, and then I know exactly how to do it. It's like this procedure. Domain has that. Range doesn't really have that. Okay, and we'll talk a little bit about that. So remember, domain is like what we can plug into the function, the x values that exist. So in order to know what we can plug into the function in math, we usually look for what we can't plug into the function, okay? So that we have a picture of what we can. In these functions, we've done this ever since the very beginning. How do we know what we cannot plug into the function? What would we be looking at? Restrictions, essentially, right? We've been doing this since the beginning. When we say restrictions, which things from our list here would fall into that category? Not x-intercepts, those are actually points on the graph, so you can plug those x values in and get stuff. Stefan? Good, so vertical asymptotes are one of the restrictions, right? That's why we mark them on the graph, because we literally can't plug in that x value, and that's why it gets separated into branches. Remember, the meaning of a vertical asymptote is that the function is undefined and can't cross it. So it's definitely an x that can't be plugged in. What other thing is technically something that makes the graph discontinuous or separated as well, because that x doesn't work in the original equation either? The holes, okay? So really, for the domain, the things we cannot plug in, you've already listed. Those would be the places where there are vertical asymptotes or holes, and those are the x's that we can't use, okay? So my domain is always going to be here, all real numbers, except, and then the x values that are the restrictions, and you've already found them in your list. Any x value that made a vertical asymptote or a hole made the function undefined. So no holes in this one, but 2 vertical asymptotes, 0 and -2. Is that okay with everybody for a domain? Okay, and this will be the same all of the time because the function goes across the whole graph. It only skips at vertical asymptotes or at holes. So those are the places that we don't have an x value to plug in. The range is a little bit different. You need to look at the graph because these graphs are odd in shape. They don't have a consistent shape. You really need to see the visual and understand what's happening, okay? If you struggle with range, I would do the same thing that we did for piecewise functions, okay? And something I do for this is I make myself, this not necessary, but if you struggle, here's a y-axis number line, okay? I'm just using this as a number line to represent y values, okay? First branch, which y values do points on this graph reach? Okay, so I ask myself, do they have a maximum? No. Do they have a minimum? No, but they have a boundary, right? What's the boundary down here at the bottom? 0. Does it hit 0? No. So this one branch has a range basically from 0 with like an open point because it doesn't exactly hit 0 and would hit everything above 0. That's not the range of my whole graph. That range is just for this branch, right? Then I go to the next branch. Here's the next branch. What's the range for that branch? Yeah, does it have a maximum or approach any boundary up there? No. Does it have a minimum or approach any boundary down there? No. Does it skip anything in between? No. So this branch by itself would have a range of all real numbers. That now added with the other one means I've already covered every y value. It doesn't even matter what this one looks like and this one looks like. The range is all real numbers because there is a piece of the graph that reaches all real numbers, okay? So my range here is all reals. Is this okay with everybody? Do you have to do this little thing I'm doing up here? No, but if graphs with different pieces bother you because it's hard to see the range as one thing because of the different pieces, it's just a nice place to keep putting them all together in one place so you can see all the things that got covered versus the things that didn't. Okay? All right, second graph. So you guys copied it. So first, were there any questions about how I found my asymptotes, holes, or intercepts for this function when you guys watched it? Was there anything you highlighted or marked as a question that you didn't understand about the list of information? All right, were we okay with the analysis and what the points looked like? And did you guys notice in here, this was a little different, but between these two x-intercepts, I knew I had to graph up here. I honestly have no idea how high or how low that peak goes. It could go really high. Can it cross the horizontal asymptote? Yes, it can, because what's the horizontal asymptote there for? Only ends, only to describe my ends. It's not setting boundaries for anything else of this function. So this could go really high. It could stay really low. I have no idea, and it's not your job to know. If you really wanted to know, go plug in extra stuff, but don't plug in extra stuff. It takes a lot of time. Be okay with not knowing. But in order for me to only graph points up here, but to connect this point to this point, do you guys understand I would have to turn around at some point and come back to it? So that was a little different than what we saw before. That has to happen in there, okay? All right, so domain for this graph. What would be our domain for this function? So remember, to see what we can, sometimes we look for what we cannot, because that's more limited, right? Looking for what we can is like a very big process. So what cannot be included as an x value of this function? Good. -1/2 and 3. And that's it, right? So domain, all real numbers, except x values equal to -1/2 and 3. Now, the range of this function would actually vary depending on how you drew it. So this does get a little tricky because we're sketching. When I say range, I want you to tell me the range of the function you drew. Sometimes that means we should have the same exact one no matter what. Like in the last function, we should all have all real numbers. That's not questionable. But here, the range would change depending on how high or how low you guys drew this turning point right here. If my turning point had passed the asymptote, the range would be all real numbers because these ones are only above a certain point, but this one meets those ones and goes completely below. It would cover everything. The way I drew it is not like that. Okay, so when I look at what I drew, notice both the left and the right side of the graph kind of look the same, right, as far as y values. They both have a boundary here at 1.5, and their points are all above 1.5 with no maximum or no boundary there. So they are very close to 1.5 without actually hitting it and being all above it, okay? Whereas this right here is more like a parabola that has an absolute maximum point. And the way I drew it, it looks like my absolute maximum point is happening right at a y value of 1, okay? So the way I drew it, it looks like my graph is hitting at 1 on that branch, but hitting every value below 1. If this is my sketch, then I want this to be my range. And the way that I say this is 2 ways, right? Just like when you guys were doing quadratics and analyzing the x-axis, this is one inequality and this is a separate inequality because they are separated, right? So my range for this graph looks like this portion, which would be said as y values greater than 1.5, or it could fall into this portion, which is y values that are less than or equal to 1. Okay. Is this all right with everybody? But I would have to look at your graph and your range, because if you sketched it a little bit differently, you wouldn't have this exact point that I had, and that's okay. I just have to be very careful when I check, because we're sketching, that what you wrote as your range matches what you graphed on the paper. Okay, Stefan?
Remember how the domain is of x equals 3?
Yeah.
Can we not do that for the range of like y equals 3?
Well, here's the thing. For this one, no, because this is an absolute maximum that stopped at a specific point. It didn't get closer and closer to 3/2 without ever crossing it. Do you get what I'm saying? So let's say this didn't exist and this looked more like the reciprocal functions, the ones with the 2 branches that we graphed before. If this had come up and got closer and closer to that asymptote without ever crossing it, then yes, it would be okay to say y does not equal 3/2, because that would literally be the only number that you're excluding. But here, there is more numbers between this and 3/2 than just 3/2. So that's why you can't say that. So you can say this cannot equal something when you have just one specific value that's being left out. But when you have like a gap of values, even if that gap seems very small of values left out, there's not a way to say that because there's infinitely many numbers in any gap unless you know that it's exactly one number that you're leaving out. Is that okay?
Yeah.
Okay. Yeah, so that's why range is a little bit tricky, okay? Because it could look different for each of us, even if we're doing the same problem because we're sketching, okay? All right, let's look at this one with the oblique asymptote. So first, was everybody okay how we found the oblique asymptote, that we did division? And if you had had a more complicated denominator, like if maybe my numerator was cubed and my denominator was x squared plus 3, I wouldn't have been able to do synthetic division, but that's okay. I would have just gone and done long division, okay? So, and is everybody okay with the fact that my oblique asymptote did not include the remainder? That that's not part of what we write? Because that remainder ends up being such a very small number. That's why we get close to asymptotes, like you guys saw with the horizontal ones. Like we're basically that number, but we're not really that number. That's the same thing happening here. Like this is such a small amount that we're basically this line, but not really this line. And so it acts just like the horizontal asymptote did. And then I scaled my graph just really convenient for that, okay? The hardest part for people with the oblique asymptote is not splitting up the graph into like another branch right here, or a lot of people want to draw something here and then they also want to draw something here because they feel like, well, you didn't draw anything in this part of the graph over here. But it's like, no, the graph's only been split into 2 sections, right? With vertical asymptotes, 2 branches. This was the split. Did I draw 2 branches? Did I draw one branch on the left side of that vertical asymptote and one branch on the right side? I did. I didn't miss anything. Okay, the only way there should be another branch is if there was another vertical asymptote stopping the graph and splitting it up, okay? So if you get confused while you're graphing with the oblique asymptote, like how many sections are there on the graph here? How many branches should I have? Look for those vertical asymptotes and be like, there should be branches in between these. How many is that? Do I already have enough? Okay, and that can help you check a little bit. All right, what would be my domain for this graph? Susan?
All real numbers except x equals 4.
Good. So she said all real numbers except x equal to -3. Is everybody okay with that? Okay, that's the only undefined place because there aren't any holes. And that's our only vertical asymptote. Okay, And our range here would vary a lot because it would totally depend on how you guys had drawn the branches here. And there's a lot of freedom here. Like I don't technically know if this is actually on this side or this side of the asymptote. Like I don't know. I know it doesn't come up here and touch this, but there's a lot of ways you could have drawn this that fits this behavior and this behavior, right? It can cross an oblique asymptote. That's just there for the ends. So there's a little question in there, and that would determine kind of how you guys wrote your range. So when I look at my range, and again, I do this just for myself, right? When I look at this right here, think parabola. I know it's not a parabola shape, but the reason it's like a parabola, it has that one specific turning point, right? And then it exists all above that or below that. So let's say I call that turning point right here, and that's lined up with my, remember my axis is numbered by 5s on the y, so 5, 10, 15, 20, 25, 30, 35, 40. This would be like a negative 40 right here for me. So what I'm seeing there is that it has a maximum value of negative 40 and everything else in that branch exists below that. And then here's the other branch. This branch hits, now this one we should have the same because were you allowed to cross the x-axis? Was anything plotted below the x-axis over here? No, my highlighting is here, but did I hit the x-axis? Yes. So over here we should have the same range even if you drew it slightly differently because all of us should have hit a y value of 0, and that should be our minimum thing for this branch. Even if you drew your branch slightly differently, all of our branches should go above that. So this is hitting at 0 and covering everything above that. And so again, I have two inequalities to express my range, that y values could be in this category or this category. So those are y values greater than or equal to 0, or y values less than or equal to negative 40. And if I was checking this on a test, I would expect to see this on everybody's with an or and then another one. And then for me to check this one accurately, I would have to go look at your sketch. Does that make sense to everybody how it could vary a little depending on how you drew it? Okay. But everybody, if you drew something like this that turned around, which you had to, should still have a less than or equal to because you're hitting a specific point that is the highest point on this. Okay, and that's what you should be acknowledging. Okay, all right. Yeah.
Why did you put 3 then positive 7? Is it also like intercepts?
So sorry, say again where I put
Positive 3.
+3.
Yeah. 7, 3, 0.
Okay, because this is not a vertical asymptote, this is an oblique asymptote. I can cross that. Remember, this is not here because the function is undefined. This is here to describe the ends. My domain is saying you can't plug in certain numbers. Those are the things that are undefined. An oblique asymptote is not the same as a vertical asymptote. Okay, it's not undefined values. It's just there to guide the ends. So basically, you should be able to ignore this oblique asymptote through the whole graph and only pay attention to it for the ends. So this part doesn't matter to me at all. Okay? Yeah, Jake. How did I get the turning point? So for this one, there was an x-intercept here, which meant I had to hit here. But when I tested both sides of it, the shading was up here. So I knew that had to be the lowest point I hit because I never crossed through. For this one, I just drew something that went down here and something that went next to this. And I happened to turn it around right here. Your turning point could be at a different spot. Like technically, you guys could draw something like this. That's totally within reason. And do we know? We don't know. And in your case, this would be your turning point and you would use that value instead. Is that okay? That's why I would have to look really carefully at your graphs and check these because we could all have different numbers even though we all have a right answer for what we're doing. Does that help?
Yeah.
Okay. All right. Is everybody okay with this one? Oblique asymptotes are definitely tricky. For some reason, our mind gets the horizontal one a little better. And then when we tweak it with the oblique, exactly what Sherilyn was asking about, we tend to like group it with some other things. And we have to remember it still is just there for end behavior. It's just instead of being horizontal, our ends go up or down. Okay. All right. For part D, is everybody okay with how this became a line? Why did it get treated after I simplified it mostly just like a line and I didn't have to like fill in any of this asymptote information? Yeah, the denominator canceled out. I no longer had a fraction, right? So if it turns from something that was fractional into something that's not, I graph it like the thing I already know how to graph. The one thing was I canceled something out of it and I had to acknowledge it, and that removable discontinuity is a hole. And so my line has the hole in it. But I am essentially graphing this line, but because this work happened, I'm acknowledging that in the very original format of this, there was a number you couldn't plug in. It was this number, -2. So whatever point you think is on your line for that point, it's not really there, okay, because that one doesn't really work, all right? So for this function, what would be my domain? All real numbers except what? Dylan? Good, except when x is equal to -2, okay? We didn't have any vertical asymptotes, but we did have a hole, which is also something that's removed from the graph. It doesn't exist on the graph. It's an undefined place, okay? Then for my range, what would be the range of the line if it didn't have a hole in it? All real numbers, right? All real numbers, you don't have multiple branches though, and you took something out of it. So you took out one value. So in this case, our range is gonna look a lot like our domain as far as how we write it, because it like used to be everything, but we just removed one little thing from it. So we would say all real numbers, that's the range of the line, except a y value of what? Emily? Good, -4. Because that's the one y value now that doesn't exist on the line because our hole was right there and we took that point out. Okay? Who wants them all to be like this on the test? People favorite. All right, last one. So this one had something cancel out and had a hole, but then still was a fraction. So we still had to do all the stuff. Notice that we did everything else though, except for the hole, with the simpler version of the equation. Once you know there's a hole there and you write it down, you've acknowledged that thing and you get to use the simpler version, okay? So what would be our domain? All real numbers except what x values? So -3 I'm hearing, okay, because that's a vertical asymptote. There's also another one. What else? 5, because that's a hole. Both of those things are places on the graph where the x value doesn't exist. Okay. And then for my range, let's take a look, okay? So first branch right here, okay, it doesn't have a minimum, and it doesn't technically have a maximum, but it does have a boundary along like the maximum, right? And the boundary is at the asymptote here, which is 0. So the way I've drawn this branch, it comes all the way up to 0 without actually hitting it, and then goes infinitely below 0. Okay? The next branch has no maximum and no boundary there, so it's gonna go towards infinity. And on this side gets closer and closer to 0. Okay, so it looks like it goes from 0 all the way to infinity. However, it does have the hole there where it skips one specific y value, and that one specific y value that it's skipping in that branch is 1/8, that y value of the hole. So what's happening is it comes up to 0 and it's filled in, but it skips over 1/8 and then it keeps going towards infinity. All right, so what I have left is basically my whole number line filled in, except for 2 y values that I don't seem to actually hit based on my sketch, which would be 0 and 1/8. Okay, so my range would be all real numbers except y values of 0 and 1/8. Is that okay with everybody? So you have a procedure to get through. So domain is pretty like you could memorize a process. Whatever the x values are of the vertical asymptotes and the holes are the places that you're excluding, okay? With range, it's gonna take a lot more analysis. There's not really something for you to memorize. You have to understand what range is, look at your graph, and then interpret it that way, okay? All right, and then there was a couple things down here at the bottom that you didn't do in the video notes. And we're just gonna write those right now, which is to write the functions. Okay, so part A says write a possible rational function with an asymptote at x equals -3. So when you read that asymptote, okay, could be oblique, horizontal, or vertical, but then you read the equation. There's an asymptote at x equals -3. What kind of asymptote is that? Vertical. Where do we find factors that make our vertical asymptotes? In the denominator. So if I got x equals -3 as a vertical asymptote, what factor must have been in the denominator? X plus 3. Okay. Then it lists another asymptote, y equals 0. Different equation, different kind of asymptote, right? What kind of asymptote is this? Horizontal. Now that tells me two things. There's no oblique asymptote, and that also tells me, because it specifically is at 0, that I have a higher degree in the denominator. Is that okay with everybody, that that's how we get that horizontal asymptote at 0? I'm going to leave that for a minute and come back to that. Like, I'm going to go back to this at the end to make sure that it happened right, because I want to fill in the other info first, okay? Then it says it has an x-intercept at 2. Okay, so x-intercepts we get when we make y equals 0, but do you guys remember what we talked about with the fraction? You have some things down here and some stuff up here, okay? Every time you go to solve this, you multiply by the exact same things that are down here to cancel them out. And then when you multiply them to the other side, them times 0 makes 0. So when you're finding x-intercepts, you really have 0 set equal to the numerator. So when they tell me there's an x-intercept at 2, that tells me I must have had a factor in the numerator that was something like x minus 2. Now, there are more complicated versions that you could put in the numerator that would give you 2 as an answer, but I'm going to stick with the simplest one, okay? Now, that's all the info, but go back. If this was your equation, would you have a horizontal asymptote at 0? No. So I can make the degree higher in the denominator by just going like that and not changing any of the info. Does that work for everybody? Okay. Now, the answers will vary, but I should see an x plus 3 in the denominator. The denominator should have a higher degree, and something in the numerator that would, when set equal to 0, give me 2 for the x-intercept, okay? All right, so same thing for part B. It starts with a hole at x minus 1. How do we get a hole in our function? What happens algebraically? Emily? Good, the numerator and denominator cancel out. So I have to have a factor that was the same. So something in the numerator and something in the denominator that match. And when you set them equal to 0, you get that x is equal to -1. So these have to be, I mean, they could be more complicated than this. I'm not like putting 3x plus 3 or something like that, but I'm just, so x plus 1. Then it says asymptotes at, and they give me an x equals, which again would be a vertical, and a y equals, which would give me a horizontal. My vertical, I immediately know where it came from. Factor in the denominator must have gave me this, so I should have an x minus 4. Horizontal is a little trickier. If I got a horizontal asymptote at a number, but the number is not 0, what does that tell me about my rational function? So horizontal asymptotes come from the degree. What has to be true about the degrees of my function if I'm getting a value and it's not 0? They're the same. Okay, they have to be the same. Remember, 0 is your horizontal asymptote when the denominator has the higher degree. If the numerator has the higher degree, you don't have a horizontal asymptote. You have an oblique one. If they're the same, then you get some other horizontal asymptote that's a number. So this means same degree. Okay. X-intercept at 5, if I think about the same process I did right up here, right? That means something had to be in the numerator setting equal to 0 to give me 5. So I'll use x minus 5. And now I'm going to come back to the horizontal asymptote. Do they have the same degree, numerator and denominator? They do. If you multiply out the numerator, the highest power of x you get is x squared. If you multiply out the denominator, the highest power of x is x squared. But right now, what would be the horizontal asymptote if I gave you this to graph? 1. Because the lead coefficient here would be 1 and the lead coefficient here would be 1. So that's very easily fixed if you want it to be different. You can literally just put something to multiply into each of these that doesn't create a new power of x, but would change all the numbers so that the numbers in front would be 3 over 2. Okay? If you know all the other stuff really well, this part will come a little bit simpler. It's a lot less work, and if you can find it, usually you can work backwards and like know where it has to be. Okay? Any questions about